So welcome everyone, thanks to be here today for my presentation. So I'm Joffrey Guilmet, I'm 2-year PhD student at ASIA, or Laboratory Immersion Interaction, and Computer Science Laboratory from University of Le Mans. Today I will present my thesis that Exploring Haptics as extended reality in asymmetric collective activity. So I will start with thesis context about PhD topics, literature review, related works, research questions, and planning timeline. And the second time with the work completed in experiment in conferences, with conclusions. Sure. Okay, so to talk about more that the PhD topic, we have color, it's better because it's complex. Here, exploring haptics as extended reality in asymmetric collective activity are profit from four key topics, and to fully understand the research, it's necessary to clearly define each of the key topics addressed in this thesis. So first of all, extended reality. That's a representation of the experience as a cube, a three-dimensional cube. We have here three important things. The first is immersions, a representation of the sensory connection between the users and the experience. And we have also extended world knowledge, that the real world information provided to the experience, that is this one. And the last one, I will not move, that's occurrence, the accepted outcome based on the user acceptations. So these dimensions are independent in theory, but in practice they are often interdependent as change affects them cross roads. So we have a small example here, that's a monitor, that's a computer, and a virtual reality headset. And you can see that the monitor is smaller than the virtual reality headset because that the virtual reality headsets have more sensors to have information for the world, for example, here. And also we have for the monitor just an input from keyboard, mouse, and for immersion, because that's the computer is just a screen in front of you, and that the virtual reality headset is just on your head, so you can see. And you have also the currents, that the fact on the monitor you can use as a mouse and keyboard, and I accepted that when you move your mouse, you have also the cursor moving, but in virtual reality, when you move your hand with the controller, it is more accurate from the reality. Okay. We have also haptics. So haptic is defined as a set of coordinates, a process of perception and action associated with tactile sensation and kinesthesia. And we talk about more about haptic communications. So it can involve using touch to convey information without the real feeling. That's to use it for guiding users, for example, or just facilitate collaborations and coordinations. We also the context, that's collective activity. So the collective activity encompasses cooperation and collaboration. That's the difference between them, because in cooperations, each person performs different tasks toward a common goal, and in collaboration, everyone works together toward the same goals. That's very tricky, but in common it is more complicated to explain them. And we have also shared decision making. The basic thing of the decision making is choosing one option surrounded by evaluating benefits and costs. And shared decision is the same thing with other people, as you know. And the last thing is asymmetrical multi-platform interactions. So asymmetry is also tricky to explain because basically it is referred to configuration in which participants interact within a shared environment using different tools, role, informations, or devices. And when you use asymmetric, we also can use this as we have a different interface, like computers or tablets, for example. And we have also two another important components, that's the directional dependency, the fact that the one user depends from another about the senses of the direction of the informations, and the timing, that the fact we have not the same action about the time. And the whole thing represents the general level of asymmetry. So you can see on this picture that low level asymmetry represents the nearest informations, and we have very large informations on different interfaces. We have higher asymmetry. And also about related work, that's very complicated because it's in exploratory research. So I read a lot about a lot of things, and I try to create some films. So here we can see that the haptic is a valuable tool for communications, collaborations, and shared decision making. It's remain too conventional from limited to simple touch simulations or applications that do not stray far from the comfort zone. Yet there is potential for shift in direction through this technology in each field. So no, the important thing was the research question: which haptic factors can be effectively mapped to informations in order to support interactions and understanding. So for this thesis, we create some materials. That's whole system, haptic system. This is a water pressure system based to create pressure filling on the forearms. And we choose it because it's very important to represent in the extended reality the more large devices to cover the whole possibilities. So we can see a different point with the description of our systems here. And you can try it on the Glowstone, by the way. And about plane timeline, we have the first thing, existing information signals in the literature review on related works, and we have 4 studies. That's important that each study need to be in the same order, the right order, because if the one not working, the others is just useless. So in our case, study 1, that's identify which haptic patterns can be associated with different types of informations. I will have an example for each one. So in that case, can we represent saving money through the pressure and uncover possible expected associations? In second time, we have examined the level of representation that corresponds to this model across different interfaces. Example again, what level of pressure corresponds to a wallet that grows in virtual reality. And in the third, we are in collective context, showing how this model can support collective activity, particularly by assisting users in shared decision making. And the last one, the contextual use, so the final use of the systems, evaluates the understanding of consequences within a shared user experience. Example, the last one, how 1% change in budget is perceived over the long terms. So, about work completed, that the first experimentation is a lab exploratory study. That's not for my thesis, but we just work together on it. And we we use that whole system with water pressure, and that's used with create a feeling of the weight, but we have some problem on we have some pressure on it, and they create unaccepted results. So we decided to use it in experiments that world our weight, comparing the use of pressure on weight as metaphor in user interface in virtual reality. Basically, simulate the maximum of number of notifications received simultaneously on the virtual smartphone, track the movement on the real hand, and this smartphone grow large as the pressure increase in the system placed on the user hands. And that also accept on the World Haptic conferences for short paper and posters. And the second experimentation, that the collaboration with Tristan here, we try to explore the haptics to guide the user. So here, that exploring pressure and sensory incongruence in short-distance VR interactions, and use the haptics system to guide the user toward a target ball with their hand in the context involving inversions, mirroring, or rotation of the virtual one relative to the real one. So that's very complex and difficult for the users. And that also accepted for Kazakh 2026 for full paper and full presentations. Okay, now for the conclusion, we conclude the analysis for the study one, what pattern associates with each informations, and the initial phase of the study two, what level of information are associated with each patterns. We also identify a bottleneck and architectural limitation of haptic pressure device, like latency or speed. We optimize it in the second time with new pump or new stops. And we also planning ISMAR response for submission status. This experiment is not mentioned in this presentation, but it's very cool. And I hope I will have this paper to ISMAR. And initiate the next experimental iteration for the new experiment. So that's all for me. Thanks.
Thank you, Joffrey, for your presentation. It was also really interesting. I was very happy to hear you. Maybe someone has a question for you? No? Okay. So personally, I have mainly one question about, sometimes you can have some cultural difference about the fact of being touch and haptic feedback. Did you find a way to manage it, or did you think about it inside you?
If I understand right, that about cultural things. That's right? Yes. Okay. That's an interesting thing because that the second experimentation, that collaboration with another PhD student from Japan University, and we try to see if different cultural feeling about the haptic device because it's different. And in fact, we have no significant differences.
Okay.